right. Good morning / good afternoon. My name is Frank. I work for Databricks. Everything I'm going to show here, I'm going to share, like the code and the notebooks. It's going to be in a GitHub repo like next week, I guess. It's not in there yet, but I can give you the link already. So the TLDR of this talk is that you're one copy and paste of a SQL command away to get access to a data stream that is like really amazing, that is provided by NASA. It gives you information about supernovas and black holes. So I think it's something really worth exploring, and like you're one GitHub checkout away from having a compound AI model that I fed with like 36,000 news articles that were posted by and from NASA. And yeah, my bosses asked me to put on this, which basically says you can't sue me. I have a flight back to Germany this evening, so you had to be really fast. It also says that I'm allowed to do forward-looking statements, which is really good. And what I want to add is that I got some help for some rough edges for making this talk happen from astrophysicists from NASA, and I'm not speaking for them either. Right, there is actually no good photography. If you're into photography, you know that there is no good photography without a story of endurance and suffering. And I took this picture 7 years ago in the desert of Bolivia, and I was so sick. This is like 16,000 feet for you above the level of the base camp of Everest, and I had altitude sickness, and I felt horrible. I brought you this picture to explain that the night sky is not static. You all know that the Earth is rotating, and this is why it seems the stars are moving. But even if you kind of subtract that movement, it's not static. There's a lot of things happening that you know from visits to planetariums, that you know from books or science fiction movies, like all this stuff like supernovas and black holes. And the thing is, this is almost always accompanied with a gamma ray burst, and that's kind of the topic of this talk. These gamma ray bursts, if you speak to the experts, they divide them into two groups. They say they're typically less than 2 seconds, and then it's like the merger of a neutron star and a black hole. Or it could be a little bit more than 2 seconds, and then it's a collapse of such a massive star. And the interesting thing is that such a small 2-second gamma ray burst has the same energy as the sun throughout its whole lifetime. So think about all the sunburns you had and all the sunburns other people will get in 1 billion years. All this together happens in 2 seconds. So you sneeze or you blink and it's gone and you missed it. And that's obviously not what the astronomers want to do, miss such an event. And this is why they collect the data. If you could see the night sky and see all these things happening, it would look like this. This is data for a whole year. The yellow dot moving is the sun movement throughout the year. Excuse me. And the orange band in the middle is the Milky Way. And all these pink flares or like blinking dots, these are gamma ray bursts. So this is how it would look like. And if you stay with me another 37 minutes, I kind of promise you that you could almost do your built-at-home picture of this. Lots of promises, I know. So this is the pro version of what NASA does to observe these gamma ray bursts, and it's called the SWIFT satellite. It's renamed now after Neil Gehrels, an astronomer who died a few years ago. And there's a couple of things to take away. First of all, this data goes into something which is called GCN, or Gamma Ray Coordinates Network. And that's also the core of this talk. This is where we look into and have some fun exploring this data. And then maybe the other takeaway is those 3 different instruments that this satellite has. Just remember the acronyms, like this BAT is a very broad one to find out if there is something at all happening. And then there's 2 more like this XRT and the ultraviolet one. And then the other thing that I find really interesting, and it becomes relevant later, is this satellite, it has some momentum wheels, and it uses those momentum wheels to slew into the right position. So this satellite reorientates itself and is pointing to these gamma ray bursts. Yeah, this is Swift, and if you want to know where Swift is, I can actually show you. This is a fantastic tool. Developer in Poland made it. So let's look for Swift. This is the orbit of Swift. Now I need to zoom in a bit. Oops, that was too much. It's also too much. I don't see it. Yeah. It's actually not that easy. There's usually a bar. Yeah. Remember what our CEO said about live demos? This is live. There it is. Okay. So this is the Swift satellite. Now it's a bit awkward position for you to see. I think it's actually flying across the Pacific. And if you look around, there's like all the other satellites, and chances are really, really good that this is Starlink, this is not Starlink, this is not a Starlink. So most of them are Starlink. There are a few others, and the green one, this is the Swift one. And you see it's kind of doing its circles here. All right. Go back to, no, this is not happening. Okay, so remember this 2-second rule that we had, like more than 2 seconds or less than 2 seconds? This was the golden rule, and everyone was living by this, and then this GRB 22109A happened. And it looks like this. And actually the hard thing was getting a picture like this, because when it happened, it blinded all the instruments. So this whole expensive big satellite, it was blinded, and all the other instruments were blinded. And the reason is that was the biggest event they've ever seen, and no one was expecting this. And the statistics are that this is like happening once every 10,000 years. And from the redshift of the light, of the radiation, they could kind of calculate that this was like 1.9 billion years ago. So sometimes in streaming data, we talk about this, event time versus ingestion time, and then the difference is almost nothing if you look at some IoT device, and then a lot of people, including myself, say, why do you even distinguish? If you look at this and you think about latency and event time, this is the worst latency you will ever see for any streaming application. This is 1.9 billion years. And you actually expect, because of the time the light needs to travel, it was also 1.9 light years away, but because of the universe is expanding, it's like 2.4 billion light years away. And the thing is, it lasted for 10 minutes, 600 seconds. So this is when this 2-second rule kind of broke, and everyone was like, wow, what does that mean? And I think it's still disputed, and it's still not clear why and how this happened. And then there was an afterglow of 10 hours. And as I said, it's like once every 10,000 years we expect to see this. And we've seen one in this 20 years since we scanned for these gamma ray bursts. And this is not all, because the instrument was blinded. Now the astronomers say what we actually want is some multi-messenger astronomy. That means we want to see more than just these gamma rays. We also want to look at stuff like neutrinos. And neutrinos are super hard to detect. They fly through the Earth without any interaction. And this is why they said, okay, let's do something cool. Let's build a detector at the end of the Earth. The end of the Earth is Antarctica. And they had like 1 cubic kilometer of ice, like 0.6 miles in a cube. And they put like 5,000 detectors on this end. The interesting thing is the same data goes into this gamma ray coordinates network. Now, if I ask you, how would you build such a network? I'd be very curious in what you come up with. If you ask probably a graduate student, they would say, well, couldn't it just be a Kafka cluster? And then you think like, yeah, but how many Kafka clusters do you know? I mean, this data should be shared across institutions, across companies, across countries. and how many public Kafka clusters that people can just access and work with the data do you know? And this data is actually also used for telescopes, for robotic telescopes that kind of learn, okay, there's an event happening, and now I also change to this location. So how would you build that? The thing is, it's unlikely it's Kafka, but NASA did exactly this. I mean, it's NASA, they can do what they think is right, and they built this, and I think it's a fantastic data stream that we should understand a little bit better. Last year, I did a session here, and I think you asked me, I had a demo where we used your mobile phones, and I was collecting the data from the motion sensors, like 5 events per second, and there was like 200 people in the room, and we did the math. It comes out to like 100 million events per day. I was live streaming demo, and I did the same demo at the Kafka Summit, and I was in the room where Judith was talking, and she's the astrophysicist from NASA, and she was exactly talking about this GCN. So this is how those two talks are connected. Now, Judith spent 95% of her time talking about what I barely could explain with the black holes and supernovas, and then 5% of her time talking about this Kafka thing that they offer. And I thought like, hey, but the Kafka topic is 5%, and the 95% should be how do we ingest the data, how do we transform the data, how do we get information out of this data? And this is why I thought I'll give you this talk. 2 important things in this presentation. Judith mentioned that they have this machine-generated data, which is the first part of the talk. But then they also have something which is more like, maybe like stored email, like a Usenet group that we had like years ago. And this is more human-generated data, which is the second part of this talk. And the other illustration that you see here on the right is kind of describing once more that this data is really used for telescopes, like the really big ones on Earth. And the data comes with a merit value. So those big telescopes, they have a schedule where they point to. So they know like for 1 hour or for 20 minutes, they point in this direction. But then if they get this Kafka message, it comes with a merit value. And if the merit value is high enough, they might reshift their orientation. That's the whole story. All right, so if you want to get started, you could go to nasa.gov/quickstart, and they give you a quick start wizard. And if you click through the quick start wizard, basically you select which topic do you want to listen to. It could be one or many. And then you select how do you want to authenticate. You have to authenticate with Gmail or Facebook. With at the end, you get such a OIDC token. And once you have this, they even give you a snippet of code, and then you're ready to go. Now, transforming this to Databricks, and if you want to work with this data, what would you do? Like, how would you work with this data? I think the obvious solution is you just put this in a notebook, and you make this notebook work. I mean, that's the easy one, especially if you use their client, that you can basically just copy and paste the code. That's the easy solution. Then you still have their solution and their wrapper, which has some challenges. I'll talk about this later. We could do this in pure Spark streaming, of course, like probably most of you could do that, I think. And then actually why I was interested in hacking this and putting this together is last year we told you you can now do the same thing in SQL. In SQL, reading from Kafka in DLT or DBSQL. So we have this read_Kafka function that works in SQL. And I always thought, like, this is so amazing if we have this abstraction layer just using SQL for Kafka. So my goal was really to go for DLT pipelines, SQL, and read Kafka. When I was starting with this, it was not available yet. You have to have this Databricks runtime version 14.3. And when I kicked this off, we didn't have this yet. So I started actually with a notebook. And if you do the notebook, it looks like this. It's like super easy. You import the consumer, you pip install it, this GCN Kafka, and then you have this consumer. And you give it the client ID that you get from the quick start wizard, the secret. And maybe one thing is they have hundreds of topics, And if you don't know what you want to look for, you get all kind of technical data, but you can't make sense out of this. So I spent quite a bit of time finding out the right topic. And at the end, I had the email exchange with Judith, and she helped me. So this is why I'm talking about the Swift data today. But this is the minimum code that you could use. Obviously, what they do is they wrap a whole lot of things into this consumer. And if you want to go the standard way, like having a standard Python Kafka client, or having the Spark streaming one, or going for DLT, you need to understand what they're doing. So I tried a lot of things, and I did a lot of mistakes. I just want to point out a few things. And I think if I tell you what I did wrong, you're probably not doing the same thing. I call it IKEA principle. Like everyone in Europe who ever studied has one of these Billy IKEA bookshelves, and no one is ever reading the manual, and that's the biggest mistake. So I did not read the manual. I tried a lot of things, and I could have saved a lot of time just reading the official Databricks manual. So this is the version with Spark streaming, and obviously the interesting thing is here this Kafka config that I need to write down somehow. And going for this Spark streaming detour at the end proved to be really useful, just to find out the right parameters. And what you can do, they have a GitHub repo, so you can just go there. It's not a lot of code. It's like hard to guess, but like, I don't know, handful of files, not too big. And you can just try and find out those parameters. Let me actually show you this. Yeah, it looks like this. So if you zoom in, it's GCN, the network, and then their client. And you see all these settings. And my first very, very naive approach was I just be very careful and copy all of them over, like, this Hassel mechanism and OAuth, et cetera, et cetera, et cetera. And that didn't work too well. And I was basically not reading the manual. All right. So what I wanted to do is use it in DLT, in our way of building data pipelines in SQL. If you don't know, delta live tables is the preferred way of building data pipelines in Databricks. It's declarative, so you just write how your tables should look like, and you don't need to care about the infrastructure. So it comes with a lot of benefits. And I actually did this. I'm going to show you my pipeline. Let me see. That's the right one. Yeah, at the end, the running pipeline looked like this. So I have one streaming table for ingestion. We always do the streaming tables, or sometimes call them ST for ingestion. And that's the SQL part that is using read Kafka. And then I actually, first of all, I did another streaming table because I thought, well, I can. Sometimes you can't. You can only use streaming tables for streaming operations, and not every operation is streaming. For example, in such a streaming table, you can only append data, but you could not change existing data. So not everything is a streaming operation. Because I could, I did this. And then later I thought, maybe it would just be, for showing you, for teaching the right thing, I should convert this to a materialized view. And then I realized, hey, this goes down from 15 seconds to 6 seconds. So one other thing I want to point out, and Ali mentioned this in the keynote, this is all running on serverless. So there's a small tick mark here, which enables serverless for DLT. I have it on. And the improvement from just going from a streaming table to materialized view, if it's running on serverless, there's a lot of optimizations happening for materialized views. One of them is that the update of such a materialized view is done incrementally, but there's more things coming, and it's getting better over time. It's like a multi-year project, and we continue to work on this. It's not completely done yet. There's some restrictions when this is not working, but the core thing to enable this is to switch to serverless. And I think it was not intended. I saw this and I thought, like, wow, this is really a good result. So how does the code look like, and how do these parameters look like? If I click here, so that was the pipeline view, and now I go to the source view. In the new DLT, it's also connecting this notebook to the pipelines. I can say connect here because it remembers I have this pipeline definition. And then you also see the new, I call it IDE view, where you have the pipeline in the notebook with the code together, and you can switch to the event log. Now, this is the interesting thing. And just to point out, the thing we need for the pipeline is this create streaming table as select from read Kafka. And then it's a whole block, and people sometimes tell me, wow, that's a lot of parameters, but that's nothing we can control in Databricks. So this is the standard parameters that you need to submit if you do it in a standard way. And a few things to point out is that it's not like the other client that I showed you. It's not all just properties. There's one property, which is this JARS config. And this is actually where I submit the client ID and client secret. And again, this is just for the demo here. You should not put the real values in this if this is production code. That's one thing. This whole JARS config thing is one string. It starts here, it ends here. It has like spaces as separators. And then a lot of people get this wrong. It has a semicolon here. So this is all stuff you should get right. One other thing is you have to use here for the login callback handler. It's a class which is called Kafka shaded because it's a shaded binary. So get this JARS config right. Don't forget the semicolon. Get the Kafka shaded right. The last thing is when you go back to, do I still have it open? No, I don't think so. If you go back to the GCN implementation, you see it's all properties. So I was working with these properties. And then at the very end, when I had everything correct, it was complaining about you're not submitting the client ID. And I had this client ID as a property. I said, no, you're missing the client ID. And I thought like, no, I can't give you this variable name. But this is exactly what you need to do here. So if you do all this right, it will just work. If you copy it from my notebook, it will just work. So basically what you need to do is you get your own credentials, run this code, and then you see the messages. And how do those messages look like? So one cool thing is if you have this pipeline view, you click on either the streaming table or materialized view. It's the same thing. And then I click here on target table, which actually takes me to the Unity catalog view, the governance view of that table. And then you see the columns, and I click on sample data to give you a better impression. Yeah, comes with a timestamp. Oops, that is actually one too far. Let me go back. I wanted to start with the first one. Let me start here, because this is what we ingest from Kafka. This is showing you the Kafka messages that we get in. Because there's one small thing, Kafka offsets, Kafka timestamp, and then the messages actually coming either from the satellite or from some ground station retransmitting the same information. And now you see this is one big message. I mean, I ingest the Kafka message, this is the message, and the next step would be understanding this message and breaking it down. Remember, I told you, let's start from the beginning. I just show you a few things. It comes with a title, and then it comes with two locations, two coordinates. And this DEC is a coordinate if you think about the Earth as a sphere and you just make it bigger, you extend it to space. So the DEC is the angle, like if it was horizontal, it was 0, and then it goes up to 90 degrees and it goes down to 90 degrees. And the RA stands for right ascent. And it also has a 0 value. I think this is where the sun is in spring. And then it can go around in a circle. So it's actually 360 degrees, but very often it's measured in hours. So it could be 24 hours. Now, the fun thing here is they put this in, you get everything. You get the degrees and you get the hours. And then it also says J2000, which means it's calibrated to year 2000 because the Earth is not the perfect sphere because of all the water and the gravity from the moon. It's kind of wobbling, and this coordinate system is also changing. So it's calibrated to year 2000. And then, this is where it's going to point to, the RA and DEC and the roll, how much it needs to roll. The slew time is when it's going to slew. And then the interesting thing, obviously, is what is it going to point to? Very often, these things already have a name. That's the name of the thing. And then remember, I told you the other telescopes can use this information and decide if they want to shift to this coordinate as well. And they will do this shift based on the merit value. So these merit values are roughly between, I don't know what's the lowest one. We can find out. But the highest one is around 100. And then remember the BAT, XRT, and this UV. That's the 3 instruments from the satellite. Now you can connect the dots, Now you understand what's in there. So I was there and I was like super, super happy because I had my DLT pipeline, read Kafka, I had the messages, and then I thought, yeah, Frank, but now how do you work with this data? Because it's one blob, it's one text blob, How do I get the data out of this? Now, the first thought was like, I can probably code this because, the key is on the left-hand side, then there's a colon, and then I get the value. And then I thought like, yeah, but you need to turn it over, into columns. And I'll show you the code. The code looks like this. We've seen the first part with the Kafka parameters. And then the second part is basically doing a pivot. So it's taking out the extracted keys, and then it's using this pivot table, and then it's doing this pivot operation. And then at the same time, I also cast this merit value, where is it, as a decimal to get it, to convert it from a string to decimal. And then, if I go back to here, I can pick either of this one or this one, and click on the target table. Then you should see this in separate. Yeah, okay, and then it looks good, and you would have this data like the RA, right ascent, and declination, and point roll, and everything you wanted to do. And now you have a table, and you can use all your SQL skills to explore this table. You could, but remember that we announced this AI BI Genie thing. This AI BI Genie thing is, well, it generates SQL for you if you're not the person who can write SQL, or if you don't want to. Now, I just assumed I don't want to. So basically what you do is any UC managed table, it could be a streaming table, it could be a materialized view, it could be any other Delta table. You right click, you say Genie space. I did this already. It doesn't take a lot of time. I could do it live. I just have one. So I'm using the one that I already have. Okay, that's it. And now you have this Genie space, and you can ask it questions in natural language. Give it a second to show up, hopefully. All right, this is it. And what should we ask it? How many events did you see? So how much data did I ingest? Let's see if it can answer this. So it's doing its magic thing, applying LLM logic, and it comes out with this number. The cool thing is it also gives you the code. I mean, I would not trust this number, to be honest, if I could not see the code, but it basically does a select count star. And then I could do maybe some other things. One cool thing is, and nobody's telling you this, I don't know why the whole company is not telling you this. We always tell you it's a natural language interface to your data. Now, depending on where you live, the natural language would be different, Like where I live in Europe, it's depending on how you count them, 50 countries, maybe 200 spoken languages. So how about, was ist der größte Wert für merit? So what's the highest value for merit? Let's try this. It's usually pretty good at this. It says max merit value, it's 101. So when I told you 100, it's slightly above. So that's pretty cool. And I mean, just to save some time, I did the same thing with the translator. You get Chinese characters, you paste them in, it comes up with an answer. And that's really, I mean, maybe not for you, but for many countries, also thinking about, I don't know, Southeast Asia, it's a big thing, And in Europe, people, I mean, they do speak English, of course, but they also have an English data model. But in a lot of countries, they prefer, their own language, and then they would like to ask their local questions. Okay, let's try something like give me, I'm a big fan of histograms or distributions. Give me a histogram of those merit values. I can do this as well. Oops, that looks not good. Show me the generated code. Okay, let me try again. Show me, well, let's say distribution of merit values. Okay, you get this table, and then you can also tell it, okay, then go and plot this table, make it a bar chart. And we end up with a bar chart. You see this, and then it's a bit weird with these merit values. You could say use bins of 5. So it remembers the context that previously I asked it for this histogram, and then now I'm not happy with the binning, with the buckets, and hopefully it's doing better now. Now it regroups it to 5, and I could plot it again. So I had this, and then I thought about, hey, the cool thing is I also have these coordinates. And remember those coordinates, they are stored in columns, but the columns, they come with all this. And I was like, yeah, I could do a better job in just filtering out the right value. And I thought, like, one other thing to show you is that, where do I have that? Is that we can still use, obviously, the same table and use a notebook, access the table, read from that Spark read table, raw events, that's the input one, and then use it to plot the whole thing. And it looks like this. Maybe you've seen my LinkedIn posting, that was the same thing. And then you have these RADEC values plotted. I think the size of the circle is the length of the observation, and the color of the circle, the color of the circle is the merit value. So if I go here, I can also zoom in. And the fun thing is, if I had a spaceship, I would go this way probably. There's a lot of things happening. Okay, so this is like to show you there's probably, the idea of Genie is to give you business visualizations, and my thinking was this is probably too much, and then I was about to pack my suitcase and I was procrastinating, and then I thought, like, hey, there's one more thing, and going back to these Swift Genie spaces, we can give it instructions. We can tell Genie to know stuff, and these instructions, they're here. So I gave it one instruction. I said, if I ask you for coordinates, then take these values, and from such a value, just take the first part until the D, and then remove the rest. And now, if I say, give me probably just the coordinates, let's see what it does. Yep, look at this, and then auto visualize. Look at this, same thing. Isn't that cool? And I did not expect this, and this is just like, not putting a regular expression, but just telling it, here's an example, and what I want you to do for this example, take the first part until the D, and I probably even described it in a good way. And if you do this, remember, this is when I told you I would like to travel here because of the density of these dots. This thing I've never seen in the other diagram, so there seems to be a whole white space where I don't know if there's nothing measured or nothing happening. I plan to ask the NASA people what's going on here, just for curiosity. Okay. So this was like one part, and I think we have like a little bit less than 10 minutes left. The other story is the so-called GCN circulars. So NASA publishes these updates, and actually everyone can publish here. So if you have someone who's allowed to publish there, and this person is vouching for you, you get a key and you can publish there as well. And it looks kind of like an email, and it's text data. So it's kind of different. I mean, you could say the Swift data also was text data, but it had a structure. I could drill down to the structure. And this is why, I mean, the full story is I thought I'm going to use a RAG LLM application for the Swift data. And then I realized it's tabular. It has a schema. It doesn't make a lot of sense using a RAG application for this. And then, I mean, since Judith talked, this is the second most important data set for them. I thought this is the perfect data set to, extract the data and kind of create a RAG LLM application. That's what I did. And I want to show you one slide just to make sure we all talk about the same thing. Where'd it go? This one. So that's the classic RAG story. So if we talk about this retrieval augmented generation, what happens is we define a chain. This chain is actually retrieving extra data coming from a vector database. So we have a built-in vector database in the Databricks Intelligence Platform. We can use one table and convert it to such a vector index table. I'm going to show you how this works. It's just a right click in Unity Catalog. And then we get extra data, like remember this 22109A. And we use this extra data, add it to a prompt, and then we run this prompt against an LLM. Now, here it says it's your data and an LLM brain. An ex-colleague of mine, Julian Simon, who's working for Hugging Face, he tends to say it's basically where you degrade the LLM a little bit to a report generator. And I think the truth is in the middle. The really fun part, if you do this, is playing with this template and trying it to tell what it's supposed to do. So I built it. I uploaded all these GCN circulars into a volume, and that's a Unity catalog lineage diagram. I wanted to build a slide like this, and then I realized, hey, Frank, you have the implementation. All you need to do is tell people, just go to Unity catalog, click on one of these tables, and then you see the whole thing that is happening, which is super cool for two reasons. One is, previously, like a few years ago, people just gave everyone access to their data lake, because otherwise it just couldn't work. Now we have this fine-grained privileges from Unity Catalog. So it goes one way, and we can define what is happening here. Excuse me. But it also goes the other way. Like here's my RAG LLM application, and that's the final table that goes into the vector database. And now talking about responsible AI, and if someone says, where's the data coming from? Well, that data from this chunk table where I have the bite-size pieces for my vector database, it's coming from a DLT pipeline. In that DLT pipeline, there's a materialized view. I use this body parameter, and this body parameter is actually put together by a subject because I wanted to keep that subject and the existing body, and that streaming table reads it from a volume. So you have this end-to-end view, which is like super cool, and I don't think any other platform can do this. So I built this, and then I took the lineage diagram to show you, and what I want to show you now is the real thing running. It's actually one notebook for data preparation. This is where I chunk those circulars, and the outcome is a chunked text, which means it has a size that the vector database can consume. And it also has a chunk ID, which is basically an MD5 hash of the same text. So it's a key, it's a value, and that goes into the vector database actually just by right-clicking on Unity Catalog and then say convert to vector database. Once I have it, I have a second notebook, and this is the RAG chain notebook. It's a lengthy notebook. It looks complicated, but I tell you something very practical. I think 95% of this code is boilerplate code. No insults if anyone is in AI. A colleague of mine built this for a completely different production application that we use internally at Databricks. He walked me through it for 15 minutes, and then it took me like, I don't know, 45 minutes to adapt this to my use case. And the original use case was very, very different. I show you what I do, because it's like super, super cool. I have one example question that I want to ask the system at the end. And the example question is, give me these gamma ray bursts that are interesting from 2024. So I want fresh data, I want new data. That's one of the things you get out of RAG. Fresh data, less hallucination. That's just the question I want to ask it. Then I do all this boilerplate stuff. For example, I define the name of this table in the vector database, and I define a retriever. And at the end, what I do is I say, give me all the relevant documents, and that's the core task of this vector database. So I have a question, and it gives me documents that match to this question. And now, if you had all this, you could basically copy and paste this into your own template and run it against the LLM. Now, obviously, this is happening in a more slick way. We have this chain, and the chain is, let me see, where's this template? The chain is basically consisting of this template, and the template tells it what to do. So you're an enthusiastic, friendly science journalist, and I want you to answer this question and use that content. And then look at this. I want it to trick into giving me links to the original resource. I say, so if you see such a GCN number, and the number is part of that, then just add it at the end of this URL. So my expectation was it would kind of generate these resources. First of all, if I talked about a template, forget about this template for 2 seconds. If I just ask the question, I get this result. It's actually a good, interesting result, but it says, hey, I have a cutoff in 2022, and so I don't really know how to answer your question for 2024, because I told it, if you don't know, don't tell me anything, don't hallucinate, that's okay. It's still coming up with results. The interesting thing is, all these LLMs like Llama 3, DBRX, Opus, they all run across this already. So they have seen these circulars. So this is not the perfect use case. And there was one learning when I thought, like, how does it know about these existing ones? The answer is, this is not really new data. This is not really what I wanted. This is not 2024. So this is more generic things it learned a while ago, but it's not really a good answer to my question. So if I really send it the chain, the existing chain, I get this answer. It's markup language. This is why I converted it to readable text. I just copied here to another cell. And then all of a sudden it says, okay, so I'm a science journalist. And then it comes up with January 2024. The Swift satellite detected this. Then February 2024, Fermi, another satellite, detected this. And then this. And then I said, well, also give me the bigger picture and explain me why this is important. And it comes up with this answer. So this is like a really nice test case where you see both things. It knows this data until a certain point of time, but then I also feed it the new data, and it comes up with much better answers. I did a test run of this, and then a colleague of mine said, maybe the effect is just because you go from the simple question to the template. And then I thought, okay, let's use the template without context. So this is where I set the context to nothing. I asked the same question with the same template, but without the RAG context. And then it goes back to this basic, I know a little bit. It's not 2024, so it's not so exciting. All right. What you need to do to enable this is you need to take, how much time do I have? Already over 4 minutes. I need 1 more minute, and then, then we're done. Let me get to my slides. This is what I wanted to show you. Okay, so it's using DLT again to ingest the data. This time I can't use read Kafka. It's 36,000 JSON files. So I use autoloader. In DLT streaming table, I say, use autoloader in SQL. I ingest all of them. I chunk them. I need a text and the ID column. I showed you this. And then there's one more thing. I need to enable this change data feed. And this is because the vector database, it could automatically update its vector table in a streaming way. It's actually using DLT under the hood. So this would always be up to date. And the outcome here is this vector index. And the vector index I use in my second notebook, where I say, well, I have this RAG template, which is the chain. And now give me all the data for this chain. And that's all I did. I'm going to put it on GitHub, and you can use it and play with this. Maybe one more thing if you have one more minute, because that's the super cool thing that we just announced. If I run the last part here of this notebook, it does the ML flow spiel. And the ML flow spiel is you start a run, which is an experiment. And once you do this, you lock the run, and you have this model locked. It's built into the Databricks notebook. You see here, these are my experiments. This is the model. If you have the model, you can click on the model. And then you can also kind of reproduce this. You can register the model. Now, this model is already registered. If I go to here, you will see my chain model. Where is it? It's this one. It's the serverless chatbot. And now with this serverless chatbot chain model, I could serve it as model serving. Now for the chain, this is announced now. It's going to happen soon. In this workspace, I can't do it yet. But normally I could just click on serve this model, and then it would show up here under model served. If it's showing up here, you see I tried. It didn't work because this workspace is not yet enabled. If I had it here under served models, I could use it like any of these foundation models, like this Llama 3 foundation model. I could go to SQL. I could just copy the SQL. Then I had to replace the Llama 3 with my, circular chain thing. But I would use exactly the same code. I would go to SQL. That was no good. Why did that not work? I would go to SQL editor, paste that code, replace this with my model, and then I would say something like explain gamma ray burst. What was it? 22.100.109a. Yeah, I mean, now you can do all kind of fun for children for 10 years old as a news article. Let's see what it does. Now that's Llama 3, but remember, I just need to replace this string here with my hosted model, which is announced now. It's not working there yet. And then you get the answer here. And this is what Llama 3 already knows about 22.109a. It's pretty good, It knows what a gamma ray burst is, the event, what it happened, where it happened. Sagitta is the location, energy release. And that's it. So I think it's a super cool data stream to play with. I'm going to share the notebooks. You can use it, a simple SQL command. Maybe one of the learnings is the first part is the SQL data with the schema, and I used Data Rooms Genie to explore it. And the second part is this text only, and I used RAG plus LLM to explore it. I think you could use it for a hackathon or just to dive deeper into our products. With this, I want to say thank you. Thank you for giving me a few more minutes. I have a thank you slide. Don't find it now. Thank you slide is gone. Anyway, thanks for being here. I have one request. If you like this session, please vote for it. Please review it. This helps us a lot. We're a data-driven company, data and AI-driven company. But these reviews help a lot. So especially if you liked it, please review it. If you have questions, I'll be around here. I'll share the code next week. Thank you. You're going to get the slides anyway. Thanks.